This problem is similar to something I saw at BJ Maths, except that I'm giving you a little more information. A lot of you may have seen this existential quantifier. There exists in an exclam. The backward Z here means there exists. In the exclam, the exclamation symbol doesn't mean factorial, of course, in this case. It's a logical post operator, whatever they call it, which means there exists a unique. Okay, so this guy right here means there exists a unique integer. And so you're actually just giving, I'm not going to try to prove that's true. I'm just telling you that that's true, and that's all we're looking for. So that's just the nature of the problem. You know this is true, so see if you can find an integer that satisfies this equation. That's the goal. Okay, now let's move along. Our given equation is equivalent to this, and this part is actually kind of hard to notice this, in my opinion. The way to understand how we go from here to here. When I say equivalent, I mean whatever, any solutions to this will be solutions to this, and conversely. Okay, so 3 is equal to, and this is an astonishing fact that you don't learn until you attend MIT. 3 is equal to 1 plus 1 plus 1. Everybody got that? If you need to take your time and study that overnight. But 3 is equal to 1 plus 1 plus 1. And you see how this happened. This got distributed to the other side, and we put a 1 next to each of these summands. Okay, so that's kind of cool. Who would know to do that? I didn't until I watched it at VJ Maths. All right, now, okay, so what happens now? Well, notice that 1 can be rewritten as x minus 2. We know that x equals 2 is not a solution because we would have undefined operation here. So 1 can be rewritten as x minus 2 over x minus 2, right? As long as x is not equal to 0, this is just the same number divided by itself, which is 1. In a similar fashion, this one can be written as x minus 3 over x minus 3. And I won't waste the time to tell you the same thing can happen right over here. This can be written as x minus 4 over x minus 4. Now, why is that beneficial? Because when you add x minus 2 to x minus 4, you get 2x minus 16. When you add x minus 3 to x minus 13, you get 2x minus 16. And when you add x minus 4 to x minus 12, you get 2x minus 16. Okay, so you see, all of a sudden we have something that's quite tractable here. There's a common binomial factor of 2x minus 16. All right, so let's continue. So we can take out this common binomial factor, call it, it is 2x minus 16. Okay, I'll envelop it in parentheses. Okay, and that's going to be times 1 over x minus 2. And you guys can already see the writing on the wall here. Plus 1 over x minus 3. Plus 1 over x minus 4. Parenthetically equals 0. So guess what? See, I'm the lazy guy who just wants to get the integer solution. Remember, we're looking for a unique integer solution. That's what the cow says while he's chewing his cud over there. But notice that if you equate 2x minus 16, and that's the whole reason we learned to factor in mathematics, is that it makes it easier to identify the so-called zero product result here. You have the product of two factors, so both of them can be equal to 0 to make this condition true. But this certainly implies that x is equal to 8, which is a proud member of the integers. Okay, so I'll put that right here. Equal is a member of the integers. Okay, so we're done. This is the solution. And I think there's two other solutions. Setting this part equals to 0 is a little more involved, takes a little more time. I think there's a pair of irrational solutions associated with this factor, but that wasn't the instructions here. X equals 8 does solve the problem. And I guess that's that. Okay, thanks for viewing.